Hello, everyone, and welcome to the fourth part of this exercise, which is calculus derivative exercise. Um, wait, for a second. Let me change the number here. There we go. Exercise 4. We are now in part 4. So last time I said a while ago, no, not a while ago, sorry. In the last video, which is in a calculus derivative part 3, I said that we can still get the derivative of this problem, which is 4x minus 1, x squared plus 2x minus 3, without the use of product rule of differentiation. So we can get the derivative of this problem by expansion first, then you get the derivative. All right. Basically, we can, oh, basically, we're going to expand this one. Basically, there shall be no parentheses here. So what we're going to do is, of course, by combining. So here, by combining, is we will distribute. Okay? We will distribute. Okay? So here, let's start first with 4x. We will distribute 4x to these group of terms to the right. Okay? So 4x times x squared, we have 4x cubed. 4x times 2x, we will have 8x squared. And lastly, 4x times negative 3, we will have negative 12x. Right? Next, negative 1. We will distribute negative 1 to the terms on the right. So negative 1 times x squared, we will have negative x squared. Negative 1 times 2x, we will have minus 2x. Okay? And lastly, negative 1 times negative 3 will give you positive 3. Then, now that everything is expanded, there's no more parentheses. Now, we can combine like terms. Okay? Or, yeah, combine similar terms, in other words. Since 4x cubed is the only term that has x cubed, we're just going to tap it here. Let's leave it be. Next, we have 8x squared and negative 2x, negative x squared. Both of them have x squareds, so we can combine them. So 8x squared minus x squared, this would be 7x squared. So positive 7x squared. Then next, we have negative 12x and negative 2x. Both of them have x. So we can combine them. That will give us negative 14x. And since we have 3 as the only constant term, so we're just going to leave it that way. Then we can now get the derivative of each of the terms because it's already expanded. Okay, you already expand this one. Now it's time to differentiate. Okay, so here we have, let's start first with 4x cubed. So since we have a constant of 4 beside with x cubed, we're not going to touch 4 here. Rather, we're going to get the derivative of x cubed. This is, once again, according to constant multiple rule of differentiation. Let me just put const multiple instead. Just to do it in a fast, hasty way as possible. So this is once again according to constant multiple rule of differentiation, where if you are told to get the derivative of a constant that has a function beside it, the answer would be a times the derivative of the function. Basically, don't touch the constant, just touch the derivative beside it. Sorry, touch the uh, variable or the function beside it. So we have x cubed, right? So we will only get the derivative of x cubed, not 4, right? So here, how can we get the derivative of x cubed? Since it has an exponent, visibly speaking, we will use what? Power rule of differentiation. So according to the power rule of differentiation, if you will recall, okay, so the derivative of x raised to n. So the derivative of x raised to n is n times x raised to n minus 1, where your n is the exponent. So therefore, in here we will have 3x raised to 3 minus 1. Okay? That's it. Now going to the second term, we have 7x squared. So here, that's the same thing for the first term. 7 is a constant number, right? It's just a constant. So we will not touch it. That's again according to constant multiple rule of differentiation. Okay? We are going to differentiate only what's beside the constant, which is x squared. Now, x squared has an exponent, so we will use power rule of differentiation. Okay? So, the power rule of differentiation is this formula. So, we will have 2x raised to 2 minus 1. Okay. Now, for the third term, we have negative 14x. So, let's have a recall that if you're going to get the derivative that of a term that has a constant and a variable, okay, where your variable has an exponent of 1, basically it acts as a letter, not a letter that has a visible exponent like x squared, x cubed, or square root of x, or x raised to negative something. Just a simple letter only, okay? So the answer here would be just the constant itself. The derivative of ax is a. So therefore, if we're going to get the derivative of negative 14x, our answer here is negative 14, right? And lastly, we're going to get the derivative of a constant term, which is 3. So remember, okay, that if you're going to get the derivative of a constant term, the answer here would be 0. Okay? That's according to constant rule of differentiation. Constant rule of differentiation is basically that the derivative of a constant term is always 0. Hence, you have plus 0. Then now let's combine. So 4 times 3 is 12, x raised to 3 minus 1 squared, plus 7 times 2, 14, 2x raised to 1 is just x, then minus 14. And there we go. This is just the same answer what we had last time. That's it. All right. Or we can still simplify this because all of them are divisible by 2. So we can factor out 2 here and we will have 6x squared plus 7x minus 7. All right. There we go. And that's it. Okay. That's it. All right. So now I'm done explaining it to you in getting the derivative of this given function where they are in factored form. So now let's proceed to the next problem. So the next problem here is we have actually a given rational function. Okay. So basically it's a polynomial but in a fraction. So here we have x plus 3 all over 2x minus 1. Let me take a look if I'm correct. 2x minus 1. There we go. Now you see, um, if we have a given fraction and then above there's a given function and above there's also a given function, we're going to use what's that again? Quotient rule of differentiation. Okay? Actually, you can use product rule of differentiation, but that would be a hassle actually, right? That would be a hassle. So, if you want to know why we can use product rule of differentiation, well, we can bring up 2x minus 1 upward, all right? However, if we're going to bring it up, what happens is that the exponent of 2x minus 1 would be uh would be changing its sign, okay? Because here, this 2x minus 1 is just simply the same as quantity 2x minus 1 raised to 1. You know, it's just the same. Now, if you're going to bring it up, what happens is that there's a change of sign of the exponent. Hence, you will have quantity x plus 3 times quantity 2x minus 1 negative 1. That would be the result. Then there, you can use product rule of differentiation. All right. Now, I wouldn't do that because for me, that's actually a hassle unless I prefer to do so. What I'm going to use is quotient rule. So in quotient rule, there's actually this formula that my professor taught us that we will use this formula, which is low times d high minus high times d low. right? D low all over low squared. What does it mean? Basically, when we say low, what's below? What's under it? When we say high, what's above it? Okay, what's above it? So basically, your low or what's below it, that is 2x minus 1, right? Then, wait. Is it? Okay, good. Then your high, that's basically what's above it. So what's above it is x plus 3. Now we have d high, d low. What does it mean? Meaning, when we say d high, it's the derivative of high. D low, it's the derivative of low. All right. So let's get the derivative of low or d low. So here we will get the derivative of 2x. So remember, constant with variable rule of differentiation, the answer here is 2 minus the derivative of 1, which is a constant term, is 0. So we will have 2. Okay. Now for the derivative of high, so here, if you're going to get the derivative of x by the application of constant with variable rule of differentiation, it's 1 plus the derivative of 3 is 0. So we will have 1 as a result. Okay. Now we're going to substitute our low, D low, high, and D low, high and D high in this formula. Okay. So let me just copy this again. All right. Let me just put it here. Right. There we go. Now we're going to substitute. Your low is once again quantity 2x minus 1 times d high is 1 minus your high, which is x plus 3 times quantity d low is 2. All right. All over the square of low, which is 2x minus 1 squared. Then you combine everything. Okay. Remove these parentheses. So here, on the first term, we have 1 times 2x minus 1. This is just the same as 2x minus 1. Because 1 times everything is everything. So 1 times x is x. 1 times function of x is function of x. So therefore, 1 times 2x minus 1 is just 2x minus 1. Minus, here we're going to distribute 2 to these parentheses. Okay? So what happens is we will have quantity 2 times x, 2x. Then 2 times 3, we have plus 6. Now, if you're wondering, why did I put parentheses? Why? Yes, I distribute 2 to this binomial, which is x plus 3. Okay, but why we have a parentheses? Because of the minus sign or the negative sign beside it. Okay, it's because of that, which is why it's important to put parentheses when you have a negative sign beside it. But what to do now? Now we will just simply distribute negative sign, which is the minus sign here, to these parentheses. So negative times 2x is just negative 2x, and negative times 6 is just negative 6. All right, there we go. Now, what we're going to do is we will now combine similar terms. So, 2x minus 2x. These two are similar because both of them have x's. So, combine them will give you 0. So, this would be cancelled. Now, next we have negative 1 minus 6. So, both of them are constant term. We can combine them. This will give us negative 7 all over 2x minus 1 squared. And that is our final answer. Okay, that's it. Or, wait. So yeah, going back, yeah, that is our final answer. Or we can actually simplify this problem by how? We have negative sign above, right? Which is negative 7. We can actually bring it down, like bring it beside the fraction. So the result here we will have is equal to negative, then that's it, negative 7 all over the square of 2x minus 1. And yes, that is our answer for this problem. All right, so that's that's it basically. Now, For our next problem, what would it be? Okay, we have this next problem here. We have the derivative of what's this? X squared minus 2x minus 3 all over x minus 3. Okay, this one. All right, so it seems like we have a given rational function. So we have a function above and function below. So we have x squared minus 2x minus 3 as as a numerator, and we have x minus 3 as a denominator. So I think you already know what to do here. You're going to use quotient rule of differentiation. But for me, I'm not going to do that. I mean, it's up to you. You can use quotient rule of differentiation. But for me, I'm not going to do that. Why? Why is it that I'm not going to do quotient rule even if it's already like a cue for us to do so because it looks like a fraction. So obviously, quotient rule is the key because I can simplify that function. I can simplify that. So you see, let me rewrite this problem. Right? We have the derivative of x squared minus 2x minus 3. That above, we can get its factored form. Basically, we can factor this one, the x squared minus 2x minus 3. This one, this x squared minus 2x minus 3, this is just the same as quantity x minus 3 times quantity x plus 1. Okay, this is just the same as this. All right. Now, if you're asking me, how did I factor this out? Well, first and foremost, make sure that my coefficient of x squared here is always 1. Okay, so that I can know the factor of this given trinomial. We have negative 3. I'm going to think two factors that if you're going to multiply them together, the answer is negative 3. And if you're going to add these factors, the answer is negative 2. So I think of negative 3 times 1. Negative 3 times 1 is negative 3. Okay. Now, negative 3 plus 1 is negative 2. So, since it's just the same as negative 2x, therefore, our factor form would be x negative 3 and x positive 1. Alright, so that's it. That's how I factored it. Now, you see, we have x minus 3 above and below, so I can just simply cancel them. So what do I have is the derivative of x plus 1. Then, I can now get the derivative of this problem. So I have x. What's the derivative of x? All right. Remember, according to constant multiple rule, or sorry, no, constant and variable rule of differentiation, the answer is 1. Plus the derivative of 1, remember, the derivative of a constant term is 0. So you have 1 as the answer. And that's it. All right. And that would be for our fourth exercise of this calculus derivative exercise. So yeah, see you soon for the fifth part.